How do fairness metrics address AI bias? Have you ever wondered how we can ensure that artificial intelligence systems treat everyone fairly? The answer lies in fairness metrics. These are tools that help us measure and address bias in artificial intelligence. They provide clear criteria to see if an artificial intelligence model is treating different groups, like those defined by gender or race, equally. At its core, bias in artificial intelligence happens when a model's predictions reflected unfair prejudices. This often stems from biased training data or incorrect assumptions. Fairness metrics tackle this issue by defining what fairness means in measurable terms. They check if the artificial intelligence meets those standards. Let's look at some common fairness metrics. First, we have demographic parity, also known as statistical parity. This metric requires that different groups have the same chance of receiving a positive outcome from an artificial intelligence system. For instance, in a hiring algorithm, men and women should have equal chances of being selected. Next is equal opportunity. This focuses on ensuring that qualified individuals from different groups have the same chance of a positive outcome. For example, equally qualified candidates from different demographics should have equal chances of being admitted to a university. Another important metric is false positive rate parity. This checks whether the artificial intelligence makes incorrect positive predictions at similar rates across groups. In a loan approval system, it ensures that one group is not unfairly flagged as risky more often than another. Recall parity measures whether the model correctly identifies true positive cases equally well across groups. This ensures that the artificial intelligence is sensitive in detecting positive cases for all groups. Disparate impact is another metric that quantifies whether the proportion of favorable outcomes for a group matches their representation in the population. If one group receives positive outcomes at a much lower rate, it indicates bias. Fairness metrics can be applied at different stages of artificial intelligence development. In pre-processing, we can adjust training data to reduce bias before training the model. In processing, we can modify the learning algorithm to include fairness constraints. In post-processing, we can adjust the model's outputs to meet fairness criteria after training. In practical applications, such as generative artificial intelligence tools like ChatGPT, DALL-E, or Midjourney, fairness metrics help identify and reduce biases in generated content. For example, if an artificial intelligence image generator depicts certain professions with specific demographics disproportionately, fairness metrics can highlight this imbalance. In productivity plugins that use artificial intelligence, fairness metrics ensure that recommendations and automated decisions do not reinforce existing social biases. This promotes equitable user experiences. Overall, fairness metrics provide a structured way to evaluate and improve artificial intelligence systems. They help translate ethical concerns about bias into measurable targets. This enables developers to create technologies that are more just and inclusive.